conferences which are nationally or internationally which is being taken place in this antennas and propagation. So I say that okay, about 60 to 65% of the PhDs is still done in the country are in the antennas and particularly in antennas. But the thing is that okay, whenever I get the thesis for the evaluation or whenever I go as an examination or whenever I, we do that, some type of competition to be presented their thesis in the 5 minutes. So then we are trying to say that okay, what for he is designing the antenna? Does he has got some aim that his research is going to be something like the production or for the some application? But he doesn't know. He says that okay, some of the papers will come out of that. That's all. But the particularly young people, those who are doing the research and other thing, first see that okay, finally this particular product is going to be in the industry which will make it, whether it is going for the 5G, now the 6G, because I always see the odd number in the communication, Professor Rajiv, that okay, odd number in the communication were never the complete. They were completed in the even numbers. 5G is not complete, right? The way that okay, 6G is coming, it is going to fill up the gap of the 5G. Like similarly, 3G was the same problem. The 3G was completed in 4G or extended 4G type of the things. So this is the type of the thing in the communication. What is happening is that why it is happening. Anyway, that okay, government has taken the decision. No, 6G is not the thing that okay, we are adopting somebody. It is our research. That's why the strong group has been made under the Professor Paul Raj from the Stanford University. So that will be, there are already 10% of the patents which are going in the 6G are from the India. So this is the type of the thing which is happening. But as this is the third edition of the conference, I feel that we should increase its horizon in the sense that okay, because see that when you are joining the MapCon fees is something around say 15,000 to 18,000. Even the government organizations which are there, they have to take the special permission to get sponsorship for that program, also to go as a delegate. But for the academic one to expect this type of participation, we have to conduct this type of conference more and more with a wide scope. And I am seeing that not much of the people from the southern India, because in microwave most of the people I know, those who are working, because see attending the conferences, all these things. So we should have this spread in the down south also, because there is a lot of participation can take place, and there is some innovative and thank to some of the industries, those who have sponsored and that JV Microwave, they are the people, because see, what had happened is the thing in those antenna people, right? Antenna is the thing that okay, you don't know its characteristics, can't see it. You require the facilities to be made, and these facilities are very expensive, because being the chairman of the 5 facilities which are coming in the DRDO, I am finding it very difficult. Everything is costing something around, the total budget is about say 800 crores of those facilities. So there are certain Indian partners have come into the picture now, the thing, because the 30% Indian make and other thing. So we require that your research, academic research, to go into the industry. Because still we use that okay, your near field to far field transformation in the case of antennas and other things is still the same Midas or some type of the Wipro or the Taiwan company and all this. Why not this can be done by our own people? You can do the type of transformation. You can do the type of the analysis of those things. And think that okay, because that microwave antenna and communication cannot be separated, and particularly in our radar technology now, that communication is our one of the sensors. Like that okay, radar is a sensor, the communication, your mobile is the part of my radar signals which is coming from the emission which takes place from here. That we take as and we process it and we get the information. So that the synergy between the radars and the communication is not there. Earlier used to be there. We used to learn a lot of techniques in our radar from the communication. Not that like massive memos and other thing. It came from the radar to the communication. So because you are doing the all digital beamforming. So with this one, I feel that okay, you can interact among yourself. And the type of the thing, IEEE is the Madhya Pradesh section is doing great, and I saying that okay, IEEE we have got now that we are just crossing the limit of the in the region 10 maximum. And with this one, we can feel that we can have this, very regularly this conference, and that we should call the industry people more. So wherever the scope are there, because yesterday I met Dr. Girish, he is from the Tejas Communication, or the that is in Bangalore. They are doing wonderful work in the communication. So with this particular, we need a lot of people to be from the industry to participate, and the industry, because our triangle is always, we keep on saying from the right, from our scientific advisor, when Dr. Kalam was there, he used to say that the triangle should be met, is DRDO, academic and the industry. But I still feel that, okay, academic side, the weakness is still there. So we have to still strengthen that one, and industry is in a big way. Because you say that, okay, microwave, we are now in the radar, nearly 90% of the except some components we have to buy, and that thing also getting designed now in the country. I think Preet will be saying that the semiconductor industry, the way it is coming, particularly Mr. Rawal, that in your Gujarat, the type of industry which has come in the semiconductors, the things are going to change a lot. Things are going to change a lot. We are not going to depend upon things. Yes, we did the mistake. We do the mistake. We did the mistake because we are, 30 years back we left that, okay, we will not work on this components or in the design of the thing. We went the VLSI design and other thing, okay, and into another thing, but we never went to very much into designing our IC thing. We did some trial in our DRDO. We had ISRO had tried in the semiconductor complex at Chandigarh, but didn't succeed. That things were changing. So we have to really put our efforts, because see that everywhere, this wireless is going to be there. Without wireless, you cannot do, and without, the Maxwell's equation, you cannot make microwave antennas and particularly for antennas. It's not only the for Maxwell's equation, whatever the way it is being told that, okay, if you don't know the digital system today, along with you have a microwave, so you are out in the industry, because everything, because your ADCs are 3 gigahertz of the 3 gigahertz samples, you can do that. But we are doing right in the S-band down conversion and doing everything in the digital domain. We are making not in the space the beam. Beam is made in the, digitally beam forming is being done. So everything that, okay, if you don't know that RF, microwave, antennas and digital circuits so well, it will be very difficult. It will be very difficult to survive in the industry. Yes, you can, teaching another thing, one part of the thing, but doing the research together, because we are making the thing that, okay, for our, satellite communication and other thing, we can buy that, your FPGA based system can change the polarization. We can change the polarization. And the type of the metamaterial, sir, you are talking about the thing, that metamaterial itself is switching according to the electronics. So it is the, smarter to smarter metamaterials with the thing, with the active metamaterial system, not the passive type of the thing, not only the periodic structure. With this one, I, compliment the organizer for organizing this one at the Maulana Azad NIT. And it is great, and I am thankful to the organizer, particularly Professor Rajiv, that, okay, to be here and sharing my thoughts to you. I am there up to the lunchtime, because I have tomorrow the great presentation in the Ministry of Information Technology. So I will be leaving this one, but you can always contact me that, okay, if I can help you from anywhere, anyway, from the DRDO or other industry also, I am there with you. Congratulations to you once again, and have a nice 3 days time. Bhopal is really a beautiful city. Right? So I came about 8 months back, Raju as a Vice Chancellor. That day I was there, but I could not meet him. Vidishan, thank you very much, and it will be definitely it will be interesting session. And one thing is there, when I was seeing this particular one, in this one, when the organizing as the committee, I am seeing that one. In this one, everybody is there in the microwave. You didn't leave anybody. That okay, I'm really surprised that who have compiled this particular one. You are talking about C.J. Reddy, you are talking about Dr. Sharma, you are talking about that Professor Paul, you are talking about Sunil and all that one. I am seeing the full list. It encompasses everybody, and the talks which is given by that from Dhanbad, that one, and it will be very interesting session. I would have loved to attend that one, but unfortunately it is not there because C.J. Reddy has already, for the people, young people, C.J. Reddy and Professor Dr. Sudhakar Rao has initiated some awards for the different places. Please participate in that one. Student community, both the researchers as the thing. One is going to be, one has just started. C.J. Reddy is the awards. And they are the very good awards, and you get a lot of support to go and attend the IEEE conferences outside India also. Thank you very much, and God bless you.
Thank you so much, sir, for giving us insight about antenna and communication. As a token of appreciation, we would now like to felicitate our esteemed guest with memento. May I request Dr. Atul Kumar sir to honor esteemed guest Dr. D.C. Pandey sir. Thank you, sir. I humbly request Dr. Deepak Punetha, sir, to kindly come forward and honor Dr. Bharat Rawal, sir. Thank you, sir. May I request Dr. Varun Bajaj sir to kindly come forward and honor Dr. K.K. Shukla sir. Thank you, sir. I request Dr. Dheeraj Agrawal sir to felicitate Dr. Rajiv Tripathi sir. May I request Dr. Anand Sharma sir to felicitate Dr. Rajiv Tripathi sir. Thank you, sir. Next, we invite Dr. Gaurav Upadhyay sir to honor Mr. Preet Yadav sir. Thank you, sir. Now I request Dr. Sandeep Kumar sir to honor Dr. Anand Yadav sir.
As we bring this inaugural session to its official conclusion, I now invite Dr. Lalita Gupta ma'am, Organizing Secretary of IEEE MAC 2025, to deliver the vote of thanks. Ma'am, we request you kindly come forward and extend our appreciation.
Namaskar. It is an honor and a privilege to deliver the vote of thanks at the inaugural function of 3rd IEEE International Conference on Microwave Antenna and Communication. The conference is technically sponsored by IEEE MP section, IEEE Sensor Council UP chapter, jointly organized by Manet Bhopal, RGPB Bhopal and MNNIT Prayagraj. On behalf of the organizing committee and from the bottom of my heart, I express our deepest gratitude to everyone who has contributed to the successful commencement of this event. First and foremost, I extend our sincere thanks to our chief guest, Dr. D.C. Pandey sir, whose inspiring words have set a powerful tone for the conference. Sir, your presence today reflects the significance of the research and innovation we aim to promote. We are deeply grateful to our guest of honor, Dr. Bharat Rawal sir, whose insights have added immense value to the conference. Thank you for taking time for your busy schedule to join us and share your wisdom. I would like to express our sincere gratitude to our esteemed Dr. K.K. Shukla sir, Director Manet Bhopal. Sir, your unwavering support, encouragement and visionary leadership have been a cornerstone in organizing this conference. Thank you, sir. A heartfelt thank to our Honorable Dr. Rajiv Tripathi sir, Vice Chancellor RGPB Bhopal. Sir, your inspiring words have truly set the stage for meaningful discussion. Thank you, Shri Preet Yadav ji. Your encouraging words have truly equipped us for the event. I would like to express our sincere gratitude to respected R.N. Yadav sir, Head of Electronics and Communication Engineering Department. Sir, your constant support, encouragement, guidance always been instrumental in making this event a reality. Special thanks to our sponsors, partners and academic collaborators who have provided technical and related support. To our organizing committee, members, volunteers and staff, your dedication, sleepless nights and tireless efforts made smooth execution of today's event. You truly are the backbone of this conference. Finally, to all our participants, researchers and delegates from across the globe, thank you for being with us. Your enthusiasm and engagement make this conference meaningful. Thank you all once again and may this conference be a grand success. Jai Hind. Thank you.
Thank you so much, ma'am, for your kind words and acknowledging the contributions of everyone who made this program possible. May I request everyone to please rise for the national anthem. Jana Gana Mana Adhinayak Jaya He Bharat Bhagya Vidhata Punjab Sindhu Gujarat Maratha Dravida Utkal Banga Vindhya Himachal Yamuna Ganga Utkal Jaladhi Taranga Tab Shubh Naame Jage Tab Shubh Ashish Mage Gahe Tab Jaya Gatha Jan Gan Mangal Dayak Jaya He Bharat Bhagya Vidhata Jaya He Jaya He Jaya He Jaya 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 He. The formal proceedings of the inaugural session is now concluded. Let us gather outside the hall for a group picture. We warmly invite our esteemed guests, delegates and participants to join us for the high tea. And we will reassemble here with the next session by esteemed Dr. D.C. Pandey sir. Kindly take some time to visit the industry partner stalls outside the hall. They have some exciting innovations and insights to share.
आज ही देख जाते हैं।
एम्पलीफायर वाले लगाना पड़ेगा टूपियाँ सर 4 स्पीकर होगा,
दो इधर टॉप लग जाए।
दो इधर दो इधर दो इधर बस खत्म। वो उनकी भी खराब है। अरे वाह भैया काम मान लिया, काम हुआ है भाई।
लगा के दिया है उसका सूचर हो गया है।
the French name came from the electronics, so there is electronics and radar development establishment. One of the total agency for radar development in the country for the defense. Right? So this is the thing. So what I am going to do is that I am going to discuss with you about the just give an introduction because I have got only 45 minutes as I came to know that okay, we have already taken about say half an hour more in the other activities, so that we will. And then what is the requirement of the antennas and what the type of the things what we are talking about. So if I talk about the radar technology, that okay, it was started by in somewhere 1904. It was started in 1904 by a German engineer, Holzmeier. What he was doing, he was monitoring the traffic of the ships at the, in the sea. So what was happening? He made some type of the transmitter because at that time the Faraday experiment was already done. So he started making and he started getting some signal. His instruments were like this. So it was the transmitter and the thing. So later on in the 1930s, that Deland, the Naval Research Lab, that okay, still if you want to learn about the radars of the conventional, that you have to read the Naval Research reports of the thing. That time it used to get published. And then okay, there was a lot of development after World War II that okay, the radar technology has gone tremendously different. It is not the type of the things what we are talking about, the thing what we have studied earlier. So if I look into the radar, what I am looking for the thing, I want to find out what is the range, what is the azimuth, what is the height, elevation, then with what velocity it is coming, because I have to identify whether it is the, whether it is a civilian aircraft or whether it is a missile or it is the supersonic thing or hypersonic type of the thing. And the acceleration with it, what acceleration it is increasing, and the target size, how big is the target size. Then we look into a target shape. Nowadays imaging also we do that one, okay, what the type of the thing. Then the target characteristics, what type of the target characteristics will be there. So what happens, the basic radar, it still remains the same thing, whatever it is. There is some energy you are transmitting. And when you talk about the transmitter, so that it is characterized by its peak power, its average power, and the pulse that we are sending is pulse width. And then, okay, you will say that, okay, what is the FPR? Then the circulator, okay, this is the thing because it is isolate between the transmitter and receiver. Then through the circulator, you put it to the antenna. So antenna, how you characterize the antenna? You characterize the antenna with the gain, with the directivity, with the effective area, and then this energy imprinted on this particular target. Target means they characterize the target by its, RCS, means the radar cross section. And from there, that okay, this radar cross section, we look for the back scatter. Right? At the moment that okay, what we are looking for the passive radar, we don't take it. If anybody is interacting with the LRD, we don't take it nowadays. We take the energy from the thing, but your FM transmitter is here. That FM transmitter, when it strikes to the aircraft and other thing, the energy gets scattered. So which is come to the different places, we receive at different places and say that one. So in this case is the back scatter, what the stealth and all that thing, what you are saying, the B-1 bombers or the thing, what has come, that one, it is this the same stealth. So that this is the RCF what we try to reduce, then okay, the energy received, and then what you do, how you define the receiver. Receiver in terms of the noise figure, then okay, its temperature, and the bandwidth, and the receiver gain. Then comes to that. The power which is transmitted is what? Power transmitted by the radar antenna ERP is the peak power multiplied by the gain of the transmitting antenna. Then when the gain of the antenna means that okay, it is the power gain means the maximum power with the isotropic antenna. So you have the directivity is the efficiency of the antenna multiplied by the gain and the efficiency, because nothing can be the 100%. So with this particular parameter, Now what is happening? This target is sending back the signal back. The way it was transmitting 4 pi r square in the forward direction, right? R is the distance. Similarly, what this target will do? This target will also return the signal, and that particular one is received by the power reflected from the thing, is the peak power transmitted, multiply the gain of the antenna, multiply the radar cross section, right? The radar cross section divided by the 4 pi r square, right? So this is 4 pi r square is the thing. Peak power what you are radiated is can be now, when this is radiating, this is also radiating, it is the 1 by 4 pi r square is the thing. It is basically that what comes in the path laws. There is nothing like the energy is gets lost. Energy is never can be the conservation of energy. It is not less, it is spreads. So r square which comes in your path loss and other thing when you do the calculation, it is 1 upon r square, which is the spread of the energy. So then when it is coming to that one, it is now the 1 by 4 pi r square into this. So this particular one will be, now I say that this relation becomes that, okay, receiver gain, if I say that one, S out and S in, so I will say that what is the power divided by the SIL, and then this particular equation is your radar equation. I'm just giving you the very short way, but you can always try to see some of the, my presentation, I will leave it to you because what I'm going to do with these things, it is for you people. Now, if you see a radar, what it has got? It has got a thing that, okay, by which it is putting the energy in the space. What energy I am doing that, okay, there is a transmitter, then the different type of the waveform, then okay, this is a type of the different signals at which I am transmitting. And the same time what I am doing that, okay, the other side is I am collecting the signals. I am putting this, okay, one torch, I am putting the energy there, and what the reflection is coming, I am collecting that one. And after collection, what I do? I do some beam forming, I do the signal processing, I do some radar processing, and then finally get the what is the information of that particular one which it comes. Now what is this base? This I will go in the next one. So basic radar functions when we are talking about the thing, first the thing, okay, you search, detect the target, right? Then after you detect, you confirm the target, whether it's a target or it is something like that, something else. Once you have done that, okay, what you do, you have identified the target, what you do, you track the target now, and track the target, track while scan, same time you are again searching the targets, and then, okay, then you have got the high speed data and other thing. Then once you have seen the target, then you classify the target. What is the classification? At the moment that, okay, morning I was hearing some word of the AI and other. We can do the AI and ML in the case of radar when we are doing the classification of the information. Because I will have the larger the data. I can put the more the intelligence. I can identify how many, F-15 aircraft, F-35 aircraft, or how many GS aircraft of the China and other things. All those parameters I can put and I can identify the thing with the classification at the baseband. I can do the, AI and ML. Otherwise, other places it is not required. Then the high resolution imaging, because as you know that, okay, that any time the aircraft doesn't go as they go in the particular formation, delta formation. See, you will always see one target. Larger the bandwidth, lesser the resolution. So you have to do the resolution of the thing, then the identification, then the threat evaluation, whether what type of the target it is. Then that, okay, when the threat evaluation means whether it's the ICBM type of the thing, whether it is that some type of the, different missiles are there. So you can identify whether it is the UAVs or say that any other thing, or say different one. Once the threat evaluation is done, then what you do that weapon assessment, then what type of the weapon are required to destroy the target. So then what is happening is the fire control. You get the Q of the target. Q of the target means that the range, azimuth, elevation, and the speed and acceleration by which it is coming. Then you do that, give the command to the fire control system. There's a fire control radar. Then you guide the weapon also. See, We have got the BrahMos, we have got the seeker, the antenna what made by us. So that particular BrahMos has got the seeker, RF seeker. But there is some IR seekers. So this particular is the RF seeker is a type of a radar. Then it says give the thing, then the kill assessment. Now the thing that okay, you say the photograph is given. Now they say the nuclear places of the Iran has been destroyed. How much it has been destroyed? You should get the information. That information also has to come. It's not the thing you hold करते आगे वो तो नहीं है ना. You require the how much devastation you have done with your weapons. And that is the information is to be done. That is called the kill assessment and the multiple aspects. Then we have got the target, what we are talking about the thing, we have got the satellites. Satellites means that okay, most of the important satellite, what we look from the defense point of view, these are MEO satellites. We are not much bothered about the GEO and the MEO. We are mostly bothered about the MEO satellite launch, because that's why we base the radars on that. Because the high distance about 500, 600, 700, 800 kilometers, it is your LEOs which move. Because the resolution will be more. You come to closer, the synthetic aperture radar will work more. Then the satellite will launch vehicle. Then the space, there are the different debris which are there. Then we talk about the air targets. Air targets, we talk about the air breathing target, means the aircraft, helicopters, UAV, and cruise missiles. And non-air breathing target is the ballistic missiles. Right? So then we will talk about the non-air breathing, ballistic. Then the ground means the land, you want to take the picture of the land, then use the land moving targets. Then under the surface, nowadays we have got one of the most important things is the plastic mines. Plastic mines means okay, they are not metallic mines. Earlier the roof you take around the thing, you will be able to get the information what you use to give your paramilitary forces. What we have got the Jagdalpur and this side and other things. The most important thing is the identifying the plastic IEDs. Then the unexploded weapons, mines, and the third one is the behind this wall. Who is the behind the wall? Through wall imaging system. Then the sea, we have got the ships, boats, dinghies, periscopes, and the most important thing by this, Bombay, the blast guys came in the plastic boats. You are not able to detect with them the coastal surveillance radar. So you have to make the coastal surveillance radar with that type of the resolution in which the human being who is sitting there, his heart beats gives you the Doppler. His pumping of the lungs gives you the thing, because the plastic boat will not give anything. So that is the type of the thing through all imaging and other thing which is of course has gone for the protection from the alarm. So radar medium environment, that okay, you have got the sea surface, lot of clutters, those who are the signal processing guys. Land means that okay, soil, foliage, wall. I don't know whether anybody is there from the IIT Roorkee, they do that from Professor Dharmendra Singh or something, they do that with the ground penetrating radars. And then we have got the air, then the weather. Weather means okay, what type of the weather it is, atmospheric layer, space, then interference. So then we have got uses of the radar. You do the search and locate, control, navigate, track, map the thing, intercept, guide, identify, discrimination power, measure, means the velocity meter, warn, track warning, dock, capsule docking like that. Okay, our group captain has gone there, that docking is the thing, it is the radar only controls that particular. And land means micro landing system means the application everywhere. So this is the thing that okay, what the information we require from the target is can be the range, velocity, azimuth, elevation, acceleration, target size, and target shape, and target characteristics. And kinds of information that radar system requires is the what band of frequency you are working, right? We have made the radar that okay, it is for last 4-5 years I am working with the OTS radar, OTS radar. And the OTS radar means the frequency is 3 MHz to 15 MHz. What is the wavelength? 3 MHz is 100 meters. You think on what the type of antenna it is. It deceives the curvature of the earth. In the sea target, curvature of the earth comes with it. So I can't fly all the time the aircraft on the top like the EWSC. So we have to make this OTS radar which goes on the surface view. Other one is the thing we have the long distance you propagate, put in the ionosphere that the reflection can take place, but then there is a skip distance and all that thing will come into the picture. So the frequency band where you are doing that one. Now say stealth. Right. So I will give you the example why I am talking about this particular terminology, because this terminology are coming very often nowadays in the papers. So stealth means that okay, stealth means that okay, what the way the aircraft with some paint and other things, that is the microwave band of frequency. Otherwise, shaping is to be shape of the aircraft is to be made so the energy doesn't reflect back; it goes different direction, and that will happen in the higher frequency, when the wavelength is corresponding to the direction of that particular reflector or diffraction. Otherwise, that okay, nothing will happen. So now if I make the radar which we have made, if you have come to Aero India, then you would have seen the radar here. It works in the VHF band of frequency, maybe about say 200 megahertz. So there is no scattering. 200 megahertz, about 1.5 meter is the wavelength, right? You require such a big structure to diffract it. Nothing will happen. So that is the type of the thing radars which will be there. But same time that okay, when you are requiring a long range, you penetrate the medium by the lower frequency. When you penetrate by the lower frequency, the same time what happens, your resolution comes down, right? Your resolution will come down, bandwidth will come down. So accordingly, so that target information, your medium environment, illumination and collector means the transmitting antenna or receiving antenna. Radar function, what type of the functions you are looking for, the radar means the tracking or say fire control and other thing. Radar waveform, different type of the wave, medium, high PRF, low PRF, medium PRF, coded signal, all the type of the thing. And the radar signal and data processing, radar data recording, radar classification, radar antenna type and the coverage. What all of these information are required when you do the system design for the radars. So the radars what we have classified as in our terminology, the radar which are less than 100 meters, there comes the ground penetrating radar and through wall imaging radars. Then comes the less than 100 kilometers, we call the short range radar. Then we talk about 100 to 300 kilometer medium range radar. Then we talk about 300 kilometers, 600 down range. And beyond 600 kilometers, we up to 6,000 kilometers, very long range radar. Why I am talking the 600 kilometers, 6,000 kilometers, why not more than that? If I draw over like India, from top to bottom, distance will be about 300 kilometers. That's 3,000 kilometers. Top Kashmir to Kanyakumari. So that take double of that, make a hemisphere of that. So I feel that okay, when that okay, our Indian Air Force looks into that angle, Indian Air Force command and control system, they draw a sphere over that. And they say that okay, 600 kilometers, if anything is that a flying is entering in that particular, we should be able to detect, right? So your radar should have so much of the capability. That is the thing that okay, I am talking to you. Somebody was showing that the mosquito type of the microlights and other type of thing. So you have to see that okay, what the type of resolution for the new generation you people have to do. We have done whatever we wanted to do, but this particular one has to be done by the new innovative techniques. Like that, okay, HF band, VHF band, UHF band, L band, S band, C band, X band, P band, K band, W band, some millimeter wave and the terahertz of the frequency. At the moment, we are not working in the terahertz. We are working up to sub-millimetric wave, and the other band we have got the radars. So antenna technology means that okay, I will not go much on that to think that okay, antenna wherever it radiates has got the three parts of the energy which is radiates. One is called the inductive region, or say that's called the fluid very close to the antenna. Then we talk about the radiated airfield region, that is the fresnel zone. Where that okay, what is the thing that okay, you people decide in terms of the phase, but I don't decide to come into the phase. I define it to the other way. Where the ratio of electric field and magnetic field is not 377 ohm, which is the free space and freedom. then that particular region is called the near field region. I take this definition both for the antennas as well as your EMI. Then away from that one, when the wave impedance is more than is 377 ohm, so then I say that okay, this is the half. Right? This free space impedance is 377 ohm, no? Square root of mu 0 by epsilon 0. Right? And the wave impedance E by H. Right? If you say any radiation radiating is electric field to the magnetic field ratio at that particular one will be 377 ohm, which is about the free space impedance. So if you see there is nothing like that in this one, reactive field. In this region, that okay, this is the near field radiated region. Those people who are with the antennas and other things doing the near field to far field transformation, they do the measurement in this region. And they do the measure the magnitude and the phase and do the Fourier transformation, get the information, or inverse the holography, they do that, okay, what are the weakness. In this one, okay, if you are in the far field region, that is the thing that okay, you are compact antenna test range where you do this measurement. So I want to go to this particular one, why the 2D square by lambda is being taken as the far field. It is the thing that okay, we expect 0.1 dB of the error, 0.1 dB error is corresponding to 22.5 dB of the phase error. So that we accept. Then antenna characteristics, VSWR, radiation pattern, gain, directivity, efficiency, beam width, bandwidth, and polarization. In this one, I will just consult you people whenever I am talking about the bandwidth, right? I am not talking about the S11 parameters, right? S11 parameter, you can say, oh, I can make the radar, the antenna from the 500 megahertz to 5 gigahertz. You say, oh, S11 parameter is less than 10 dB. But I am saying at the instant of the time, how many frequency components are coming from your instantaneous band. That is the beauty of your antenna. At the instant of the time, you should make a structure in which, at the instant of the time, like this particular door, how many people at a time you can go? If you not go in the same time, then there will be a delay. Right? So that is called the instantaneous, and the particular SAR people, or say like that, okay, you are from the SAT, you are people more talk about this particular one. So the bandwidth is the thing, polarization is the part. So these are the simple definition of the thing. Then we have got the different type of the thing. Nowadays, you have got different MATLAB. You can write your own program, can generate the Cartesian coordinate. You can do the 2D plots. You can do the 3D plots and see that okay how these harmonics and side lobes and other things which are coming into the picture. Then okay, gain means that okay it is with reference to isotropic, and that is just like okay, passive antennas. We talk about the gain. That is with reference to isotope. When I am talking that active antennas, this definition of the antenna is still, it is not there in IEEE. It is not there in the antenna thing. Active antenna gain, what the way you will decide, it is not known. At the same time, the reciprocity relation which was to be there is not applicable for the active antennas. This is another important parameter here. Rest of the thing, efficiency and other thing, how good you make the efficient antenna, the better will be the gain. This is the last one. Then of course we talk about the side lobe labels, and then okay, the null depth, what is the bandwidth, which is the 3 dB bandwidth, but the power falls about the half, right? So that particular bandwidth we talked about the bandwidth of the beam width of the thing, and this beam width decides that okay, how much exposure you are talking. You must be thinking I am talking from this one because that's the way that the major weapon is not effective for the UAV killing. Because this you require the collimated beam and put the energy of milliwatt per centimeter square at the particular place and burn that place. But in the case of Bharat weapon, depending upon the antenna beam, you can expose the whole thing. When the people are coming with sending the strands, it's coming like the honeybees. That time the laser, how many places will put the laser there? So that's the thing that that type of the high power microwave weapon will be one of the most important aspects. So that's why this beam width comes into the picture. Then the polarization is the direction of the electric field while it is going on. So you have got the linear polarization, or you have got the circular polarization. Circular means right-handed and left-handed. And ISRO people use a very often this particular one. have got the elliptical polarization, then in that way you will have to say that what is the actual ratio, what is the sense of polarization, same time the spatial. So now that when we are talking about the things, we can classify the antenna or radars in the principle of how the antenna is working. If it is antenna is rotating like this, it is mechanically moving, that's called a mechanically scanning arrays. When it is electronically scanning, right, I can change the phase and can make the phase array antenna accordingly so that it can be the that active phase array antenna or passive phase array antenna depending upon what the device I am using it. And this particular one, this electronic scan array antenna can be fully distributed, which each element has been put, and then semi-distributed when the multiphase type of the things we can have. So these are the three type of the radars. Depends upon the thing we have classified by this antenna. So in this particular one, we used to have the transmitter used to be a tube-based transmitters. Can be magnetron, can be plastron, can be TWT, can be crossfeed, any type of the antenna which will be there. And the conventional, LNA can do down convert at the maybe 30 megahertz, maybe 20 megahertz. That time the ADCs were like that. Then you do the digital signal processing. Earlier used to be analog signal processing, later it became the digital signal processing. You have got DSP and other thing. Then you do the data processing and get waveform. And the exciter means the waveform what you are making it the thing, what is your PRF and other thing. Then came the word of the passive phase arrays. Passive phase arrays means that antenna, it is a type of the passive element which is giving the phase shift to your antenna, right? Each element is another thing. So it was a passive phase arrays, and in this one I will try to mention that this particular phase array antenna, which is the Akash missile system, right? Or Akash missile system, the radar which is a tracking radar, is this passive phase array, which is called the Rajendra class of the radar, and its phase shifters being developed by the IIT Delhi Professor Bharti Bhatt. And that time the Professor Sipan Paul was a student to the Professor Bharti Bhatt. So that is the thing which changed the real scenario. The CRL Ghaziabad is making that one. Still they are making these particular elements. Each element has got the 4,000 elements, right, of this passive phase. Some other time we will discuss about that one, so that each one, it is the lens type. So you have got this is the phase shifters. Here you have got a lens, you put the wave on that. So this wave is the spherical. So what is happening? Center will be meeting there, top and other things, you have to give the phase shift accordingly. And then you can say the PCM is a phase control module. You can put it anywhere that you change the phase. You can do the phase shifting. Then comes the active. All of a sudden they started coming in the active, and the late 80s when it was coming into the picture. That time we thought that it will never come. It is going to be so costly affair and other thing. Within no time, by 99, 99, 95 and other thing, it realized prices went coming down. The elements TR module, each module, you have got one dipole, is fed by the TR module, each is the transmitter, and receive R. At the one L band, it was already 1 kilowatt. Each element you are feeding. So this is the type of the technology which has done. So from 2004 onwards, most of our radars have become the active radars. Active or passive radars, but they are nothing like the tube-based radars. Tube is still being taught, but what I am saying that it has got all application. You can have the micro one, that is one of the most important applications. That it is the its cost is so small. So this particular one, you people have to believe. Sometimes tell that okay, you stop it. Right. So then we talk about the single beam. You have got the procedure type of the antenna at the thing when you get the beam. Right? Or so you can have the cosecant square beam. Cosecant square beam, we make it because the energy should not go in the ground. Why should I place the energy? So it is a cosecant square beam which will be there. And then we have got the, this is the cosecant square beam for the transmitter and receiver. We have got the pencil beam. Then we have got the multi-beam. Earlier radars were only 2D radars, we are getting only azimuth and the range information. There is no information how to get the elevation, right? So elevation means that you require the multiple beams. So this is the thing that the concept of the multiple beams came into the picture. These are the things whether you feed or you make the antenna itself by radiating all different elements. So transmit you have the plan beam and the receive you have got this receive beam. So that you use the Butler matrix or something like that to have your beam forming network. Then the phase array, okay, this I need not have to go because this is the way that okay, technology changed the complete thing in the phase arrays, and this is the thing that okay, you can go on to the communication. So you must be seeing this particular time of the thing that if you change the phase. So advantages, there are so many advantages of the active phase radar, large power aperture product, beam agility, fast reaction time, automated fast reaction time means that okay, if we have got the mechanical rotated antenna, if the 60 RPM is like 1 second, only one target I will see. Second time is the 1 second. But in the phase array I can go in the millisecond. 1 millisecond I can go from 1 millisecond. How many times faster it will be. So that is important of the thing. And the other one is the graceful degradation. Earlier days, if the transmitter is gone, means that your radar is down. Right? You have got TSD 1954. That's our air defense one, which is in the beta, which is there in the Chimney Hills in Bangalore. That is in Gorakhpur also. That is in the IIT Kharagpur, near to the IIT Kharagpur. So what happens that okay, it's about 20 megawatts of the flash storm. If flash storm goes, means that this radar is gone. Means that okay, you can't see the multiple targets and whatever the multiple beams you have. So, but the problem is that it increases the complexity. So you can think that okay, if I have got 5,000 elements on the TR module, each output is coming in the coaxial cables. 5,000 cables you have to handle in that radar. 5,000 cables, and it is a coaxial cable. How difficult it is. So all of a sudden what the RF on fiber, it changes the complete scenario. Everything comes on the fiber. You don't have the EMI problem. You don't have the complexity problem. It looks so elegant and other things. Your maintenance and everything becomes a very important. That's the type of the thing. These are all phase shifters. What I was talking to you about the passive phase shifter means that okay, you radiate by the lens, then this is the antenna, so accordingly you will change the phase. Then okay, you have got the TR module type of the thing that okay, you got each element is required. And now this is the integral part of that. Right, the thing that okay, in that your chip is coming on the chip itself, now the IC is there. Like that okay, your mobile phone also the ICs are there. Now I mean the antennas are there. How they are integrated, where the thing that okay, the person who is the thing that okay, who is the you talk to the mobile phone people, they say that okay, we hate the antenna people. We hate the antenna people because you require the more space. More the space, the power aperture product type of thing. Stop it. You just give me a signal, no, that's why, because this will go, otherwise there's nothing like. So this is the type of the thing that we can put the scan, then we can track the different range, we can put at different types, track while scan. And this is the thing that okay, digital beamforming, what we do that okay, just give you a concept of this. We have got the RF translator, then it goes to ADCs to the digital down converter, digital converter multiply the weights, and then it will give you the beam forming will be there. It means that every beam you can form in the digital. Life is so good. 5G is same thing, 6G is going to be the same thing, massive MIMO is another thing. After the digital beam forming, you can put the beam wherever you want to put it. Okay, this is one of the digital receivers, so that it is this is the array, this is the cavity back patch antenna, right? So we have in LRT our elements of the antennas are already been decided. We don't do much of the work on them. Now the thing, how nicely it has been down converted, how nicely you put the digital beamforming and other thing. Otherwise, folded dipole for the LC antenna, folded dipole means you require the 1 gigahertz of the bandwidth, you require the cavity pack, you require some type of the Vivaldi antenna in some cases. So these are the elements are well established. So what we do that, okay, whenever we are using these antenna, we don't take it, instead of we use the whole array as a receive module, right? As a receive module, each one. But transmit we measure only put this center portion, some smaller one. Lesser the number of the element, larger the bandwidth, right? So this is the type of the thing I must have to done it here. So this is the different beam on the receiver, and the red color is for the wider transmit beams, right? So you have got this is the whole beam, so that you can put one beam in the receiver, so you can see the multiple target, multiple things in this. Radar antenna system, this is the thing that the first time that, okay, this was the multi-target field artillery radar system. It was made in 70 before my joining to the DRDO in 1981. So this was the radar, this was quite successful, I will say. This is the time we used to have the prototype A, prototype B, prototype C type of the thing. Those who are the senior people, they may be knowing about it. Nowadays, there is nothing like that. Prototype A, B, C. There is directly you have to make, and it has to go for the production. So then we have got now I will say you that, okay, for army we have made that, okay, this is the BFSR, that is the surveillance radar. This is the Barani radar. This is the radar that, okay, which was in the 90s, which is radar we made the Indra radar, Indian Doppler radar, which was the two vehicle mounted one, right? Two vehicle means one place is the generator, other place was the signal processing, and there is transmitter. So that particular one has come in the 180 kg. It is a mule mounted one, the one you take in the range of the 50 kilometers for the load detection target. It was the thing, means after 20 years the technology changes like this. So we have got in the army also, we have got the air force, we have got the Indra pulse compression, then we have got the Rohini radars. You must be seeing most of the airport, particularly the Pune airport, if you see that this radar is all here. Then we have got the FLR, field level radar. This is the thing, tracking radar. Then we have got the NPR, this is called the Arudra radar. This is called the 400 kilometer range with the digital beam forming. Then we have got the long range tracking radar. Then, okay, AWS, what you see, the Netra, which has been used. So I will just move out of these particular ones. So you can. This is the BMD radars. BMD radars means that this is in the NCR region. So it is range is about say 700 kilometers. 700 kilometers means it sees the BMD, means the terrestrial missile defense system. Same time that our satellites which are coming around them. So this is that particular one, and then we have got the this is multifunction radar. With the BMD radar will detect the target. It will give the search information using the L band. Once it gives the information, then it will give it to the dispute to this particular multifunction radar. This NFCR. So NFCR will do the controlling of all the targets and bring it to the closer to the what the missile range it is. Then it will give the cue to that one accordingly it will fire. And this is the stick mounted radar, because now we have made just our own ship. And own ship meter is 130 meter by 30 meter. And then this is called the S-band radar, and the thing that Professor Rajiv is there. That I want to tell you that we have got the problem of these radars now. All the radar what I have shown, they were from the 3.1 gigahertz to 3.5 gigahertz. It is a 400 megahertz bandwidth. Your communication guys, I take them as the communication, they have made the that from the 3.3 to 3.5 gigahertz, you have to leave the bandwidth. And we have been given the 10 years of the time. In 10 years, you leave the particular band, because this is for the 5G, sub 6G. So now that we are left, so we are left with the 200 megahertz. So when that this information goes that other side of the thing, they are very happy. Now I have to jam only 200 megahertz on the band. Earlier the 500 mega, I can do the express spectrum and all that one. With this one, it looks like that. Okay, another one is a very interesting one. Is what I am going to tell you. This is going to be our active aperture radar, our LC Mark II. Even it will go for the for the AMCA, which is going to be the most important radar. This is for the synthetic aperture radar, which is going to be in the vehicle belly mounted. And this is the thing that DRDO has gone in their space. This is the upper level antenna, what you are talking about that. So this is going to be a MESA radar project, which is the Ku-band. So this will be tying in this. So is this one? This is the OTS radar. Because I take the credit, it is in the it is near to the Gujarat Dwarka. Okha is the place. So it is the this antenna size is 55 meter long periodic antenna, and the other side is the array of the 600 and 230 elements. With the back side is the protection, so the beam goes in the sea. With this one, I was talking to that, okay, we don't read it, we receive, so that we can get that one. So this is the dipole type of the arrays. This is being made in the thing, so this is the type of pattern. Anywhere the signal comes, we detect that particular signal, and so this is the passive radar, what we call it. And then we have what I was talking about, the VHF. These are the antennas for that. This is the, we have log periodic dipole antenna. UHF radar antenna still we have not made it open to the literature. So I will stop it at that one. We got this one. With this one, thank you very much. And any question, I am ready to answer. Yes, sir.
Sir, I have a question, sir.
Yes.
I'm Dr. Subbarao, assistant professor in management. I also worked on antennas, and we also do various antennas. We have also talked about antennas. There are various types of antennas like parabolic antennas, dipole antennas, field array antennas like that. And I heard that a lot of research is going on in our LRD, DRDO based on phased array antenna. In fact, my first two antennas were measured in our lab only, sir, with your permission. And my question here is, so what type of research is going on antennas in our LRD right now? In addition to phased array antennas.
See, phased array antenna is the thing that what we are trying to do now, the TR modules which are. The TR module we are bringing in the chips. We are designing that one, and it is the radiating element should become the chip part. Reducing the size, because at the moment LRTR3 which is there, this is the thing, I have to modify the road from Bangalore to when I come to the NCR region. There are not the places, so I further want to I aim is that what is going on the by phase array is the thing. See, we are looking for the larger attachments, and one more, area is less, power is less. Right? So what we are doing that one is the thing that is TR module to the antenna, and same time the FPGA based type of the polarization. FPGA based type of the polarization change of the, which is becoming the RF antennas and the digital is getting combined.
So one more antenna you have mentioned, sir, digital array antenna.
The digital array antenna, that is our DARPA program. So what we are doing, the antenna elements are same thing, that it is 70 back, but what we have done that okay, at the S band we have ADC. That S band it doesn't have that you don't have the that is LOs and other things. Directly at that band you are converting S band.
So one last thing is
digital TRI. That's all.
one last thing is my scholars are also here, sir. They are working on antennas. So what type of research topics you can suggest to them?
They can, they can come, that you bring them and that interact with the antenna group. We have got the antenna group of something around 20 people. Different people are working in the thing like that, okay, high power microwave, there are the people are working where the gain is required about 50 dB. MPRDC making the source for that one is the relativistic microwave. So is the Cascadian antenna and the thing that when he is radiating a gigawatt of the power, the air breaks now. Right? So type of the SF6 type of the balloon and other thing has to be put to avoid that air vector. So that element wise, there is something like that, okay, one of the most important field which is happening in the but I see that, okay, metamaterials using the antennas and other things, but for us that, okay, we have tried it. Of course, that, okay, there is a professor from IIT Patna, some project they are doing for the Ashutosh Kedar. So there is, we are trying to see that, okay, how this metamaterial and other thing can be done. And the last one is how to increase the bandwidth. Not the bandwidth, as well as because of it, that's the
Hello. Yes, sir. Sir, actually, I want to ask, like, in radar technology, where do you see the quantum theory or quantum-based radar and application of quantum entanglement to detect the stealth type of bodies or whatever object we cannot detect with RF?
See, I was also following all the papers which are coming on the radars for the quantum radars. We have got in that one of our radar conference also, there was a session we kept and the person was supposed to come from outside and he didn't come. Then we thought that, okay, what the way he is talking about this quantum and the quick, qubit and other type of thing. So, but recent paper has come that, okay, don't waste your time for the radars you put in this. You use the AI and ML, right? You will get the better information rather than it. For the communication, it is good. I was talking that, okay, your cryptography and other things, it is good. And if you want that, I have got my mobile itself a paper, you can take from me that the person who has written that, okay, who spent about say 15 years in talking about the quantum radars, and now he says that, okay,
I'm just asking, like, what is the
But
view of government and you, like, what you are suggesting to the
see,
government? Like,
in fact, that, okay, we are thinking that as the quantum radars will come into the picture, is the thing, we will get the larger the better. So that particular thing has gone in the photonic setup, right? We are already work on the radar is already the trial, the polar the trials are going on. So my bandwidth has increased. My information which comes from the radar, so much of information, that I can put in a, larger the bandwidth, larger the information I can put. I can give the target photograph. Right? All these things when I do the multi-fusion of the targets. So that is in the photonics, but the quantum that's why I am saying that, okay, I followed this particular one and they told, that quantum means that, okay, they tried to solve the Schrodinger's wave equations, right?
Yes.
Right. E5 is equal to S5. We used to say there is a Kalpaksh in our olden days that, okay, what you give to the phi, you will get the eigen functions and all that. He has solved that particular, but I don't follow what exactly he is talking
no, my just question is, like, how you are suggesting
we
to
are
the.
quantum radar at the moment we are not.
Okay.
LRT is not there, but we want that, okay, who is going with the solution of the sum of the problem.
Anyone else has?
Just last question.
Okay. Sir, as you are saying that we are trying to bring those TR modules in the chip. Is there any application in DRDO where we can use that antenna array also inside the chip? Means on chip antenna type.
Yes, we are doing actually what we are doing is the thing, we gave a small work to Samir Chitai, right? In the packaging, right? It's a system level packaging, it's a tile. So in that particular one, it is coming as a one tile. So like that you are building tiles, so it will be like that you can put these tiles to hold the thing.
So antenna also inside the chip.
Antenna will be the part of
The chip.
yeah.
And what particular application, sir?
It is the thing, it will reduce the size, it will maintainability, another thing, you put like a brick, how fast the thing. See, question is that, okay, how fast you make these radars? See, India is not the like a, iron dome that what the Israel is. Israel is a small, you cannot put Madhya Pradesh type of the thing. You have from one end, other end you are in the Gaza. So, our iron dome, you think that, okay, where many missiles you require to do that? Side is top is okay, but what about the sides and all that when it comes from the sixth and other part of it? So that's why that okay, radars at the moment, see, I was showing you the ship radar, the shipborne radar, SBR. So it's one phase itself, it's a two-phase radar. One phase is going to 6 meter by 4 meter. 6 meter, you can just see the, about 3 times of my height. Right? So that particular one, the Bell is not able to give me 8 months. So if a radar is taking about say 2 years or 3 years to come as a whole radar, so then are we ready for that? So that for that must be required.
As you said, when we are putting these antennas inside the chip, the size is going to be very small. So the range what we are expecting is not correct.
See, we have got so many other issues also. When
Yes.
you put in the ship, you only get to not put the radar on this. There is articles also.
Yes.
Articles also launched from there. No? So the radar beam is looking at what the field is, the radar will be there. So that also it has to be listened. So there are so many other issues which come to my other part of the mind. One is the EMI, EMC and the electromagnetic environment. So that's ties base and other thing what you are saying, it is going on in a very big. A futuristic radar we are doing on this.
Thank you, sir.
Thank you, sir, for such an engaging and enlightening session. I request Dr. R.N. Yadav, sir, to kindly present the certificate and conference kit to Dr. D.C. Pandey, sir, as a token of our heartfelt gratitude.
Thank you, sir. Moving forward, I now request Dr. Bharat Rawal, currently serving as Professor and Head of Department of Computer Science and Digital Technologies at Grambling State University, Lausanne, USA. He is a session researcher, academic leader, inventor, and entrepreneur with a strong background in quantum computing, cybersecurity, artificial intelligence, and blockchain technologies. Now he is going to present PPT on the topic, the face behind generative AI security and privacy in the era of quantum computing. Please, sir.
Testing. Thank you. So, Dr. DC Pandey gave excellent presentation. Antenna and radar both at the same time. So I hope that you guys have very fine tune with communication. It was wonderful presentation, and it's very enriching. So today I'm just going to talk about. So this presentation in talk I have several elements. So I will try to touch cryptography. I will try to touch AI. I will try to touch quantum. And today's my goal is to assuming that the audience, I try to stay a little bit high levels. So I will not go into deep, so at least you guys can digest and you still float on the surface, so you don't go deeper. Okay. All right. So my name Dr. Bharat Rawal. Currently I am with Grambling State and Louisiana Tech. This is in the Louisiana. Before going to Grambling, I was Duke University and Penn State. These two universities, and now I am in Louisiana. So currently we are building a center of quantum AI and cyber. Like it's kind of the world's best facility. I already built previously one of the center, and this will be the second. Within 3 years, this will be deployed. And so some of my students who are working with IBM, Microsoft, Deloitte, US Air Force Space Command. They are at high ranking, and one point of time they did PhD under me, and we are working some very innovative things. So I try to provide a little bit on idea. So how many of you are using ChatGPT? How many of you use ChatGPT to generate your paper? No? Okay, very good. And okay. So AI, robotics are like more than 60-70 years in the industry. They are always go peak and valley, like they jump, and so they take some and you might have noticed in 2022 actually 2022 AI become industry. Everywhere people are start talking about AI, right? So whatever you do, you try to put the flavor of AI, like topping, what we call, or Gujarati we say vaghar, like we try to give some kind of special taste. Okay, so putting AI make different. I try to give you some kind of flavor here. I may not able to give more whole, but I try to explain that. So what is this generative AI? Like what is the difference they made in ChatGPT, right? So I said AI been like more than 60 years, and robotics we develop so much. So in the audience, anybody can tell me what generative AI means ChatGPT? What is difference than previous AIs? Any?
Generative AI is actually learning from whatever we are just discussing with him with that particular portal. It is actually learning from our statements also. That is generating the statements as per our prompt, whatever questions we are asking.
Okay, very good. So let me make a little bit, more simplified, I think, to make sense. You are very true. So generative AI means previous AI you ask question, it will give you answer, right? So it doesn't give, but now you ask and it will generate whole report. It generate video, audio, images, digital. So that's the big difference with 2022 ChatGPT. I am involved with Penn State. We built like 15 years before. I'm telling you, I may be the first person, but unfortunately I dropped the idea. I spent a lot of money as a CEO of the company. We built a core AI platform, okay? And as soon as, if you get chance, right now it's be purchased by government. So I'm not able to talk about on that, but idea is that, AI been there and the difference what we came. So before I come to the the generative AI, let me go back a little bit on the why this something which we are using Alexa and a lot of voice command things you were using, right? So Alexa and all other these the tools which provide you anything you ask, it will give you answer, but now they are also enabled with generative AI and they make like more one. So previously, like what was the difference with current one? Previous one only can give one answer, can give you like you ask the chat, it can generate kind of ask question, give you one answer, right? So now with generative AI, it can generate whole whatever format you report you like, right? So if I say exactly how you provide the prompt, and based on your prompt, it can give you whatever way you are expert in, that way it will give you generate the report for you, right? So I say this is the most of the development happen behind is mostly on the because of this neural network, right? So neural network is nothing but kind of how our brain functions. The idea came from that human brain, and we try to develop the network such that they can communicate and give you better answer. So larger, deeper the network, you have a better answer. So I try to, so those people are have not understanding, I'll try to give, but that's assuming that understanding. So this is your neural network, right? So you give input, in between you process this, and you get output, right? So, but now what is the difference between neural network and deep neural network? Okay? Deep learning actually. So machine learning and deep learning, the kind of, if your network get expanded, like become bigger and complex, and that at that level it become the deep learning means very. So idea is here, like in the process being gone through so many predictions and forecasting. Technically this neural network, the AI is nothing but prediction mechanism. It's simple statistics. And trust me, I built the Turing test for AI. Okay, any AI today cannot solve third grader problem. Okay, this right now you are here. I'll give you one problem. Okay, this is very simple, and use any best AI and get answer from that. Okay, trust me, it won't able to provide you answer. Okay, so the problem is statement is like only this is third grader. What we learn: add, subtract, minus, multiply, divide. Now at least if you're in the third grader, right? So if you start with, let's say I'm giving one simple example where is the limitation here. If you start with any number, okay, increment, the rules is start random number, pick up any number, increment by 1. Okay, so create the sequence based on that, right? Let's take number, and let's say I started with number 1. I increment by 1, right? So next will be 2. So the rules here is like that. So any element you generate in the sequence should not be derived either by adding previous element, subtracting previous element, or by multiplying previous element. So using these rules, like very simple, three rules on complexity. So you start with, let's say, 1, and if anyone in this class, okay, in this room actually, if you can get 30 correct answer, okay, use any best computer, supercomputer, and get first 30 element of sequence, and ask AI to find the pattern and deliver, okay, I can give you 1 million, okay, I can do much faster than any supercomputer or any quantum computer, particularly this sequence, because this sequence I have invented. The sequence name is called no-sum sequence, and this is the Turing test, like very simple thing. Okay, so but take a video, you go home and try. Start with use like pen and pencil and try to see how many elements you can find, right? And compare, ask your AI and see that how good it can go. Okay. So that's I give you little homework here. So mainly this how this AI work, right? So mainly I say that this neural network you train more and more data and complex and data larger than your neuron complex network and give you better prediction. Idea is that you try to smoothen every time your prediction come. We try to compare how close to accurate prediction, original prediction, okay, accurate value. So try to, whatever error, try to minimize over and over and over. So at some point of time, you have, very close to, the correct prediction, absolutely. So this is mainly from, learning your structures, whatever the patterns follow and all, like, so that can be done. So behind this generative AI, like two main model, one we call generative adversarial network. So generative adversarial network, and other is we call the variational auto encoders. Okay, these two AI component, the model, mainly a function there. So how generative adversarial element work? Okay, so generator, that's like two, one is generator, one other is discriminator. So generator does generate the data, and discriminator, you take some data and try to generate fake data, and discriminator come and try to see, okay, whether this is the real data or fake data. So this is kind of zero-sum game. So this keep going on, and ultimately it eventually become fine-tuned. So this is how games, this is the most popular one work. And other one is a variational, encoder, so it's autocoder. So take the large information and to put the lower dimensions. And when they share with this lower dimensional, and it can expand from lower dimensional to original space. So that's kind of the how variational autoencoder function. Okay. So, okay. Now this is the key thing here. You might have not imagined anything. Okay, why government agencies are restricting user not to use AI anywhere in the world. What is the reason?
So the first reason could be the data process is on the servers of China mainly, because the thing is that most AI that are being used, either be ChatGPT or DeepSeek, have the servers based in China, so that can be a main reason, because data is the main thing.
Very good. So they are not afraid. They are not saying that you use AI to generate, you didn't put your brain, you use AI. That's not a problem. Okay. So now, like those, we are old, I'm still an old style person. I like to learn hard way. I don't like somebody in microsecond generate, give me answer, right? So, but that is okay. We need to. But main problem you say your data and train. So idea is that data has been taken on the server side, and they can see what you are asking, what you are doing. So everything will be there somewhere. It will be in the server, right? Okay. So this is the story. What you right now you say we need to worry. This was the story before 10 years. Okay. So today we are not worrying about the data as on the one server in China or in US or any country. Okay, that is not the problem. Nowadays, this AI generator, the large companies, they have a mechanism built into that will allow you to train your data without revealing or underlying information of your data. So you don't need to send your data. Your data still stay on your laptop, on your computer, and still. So this is called distributed learning, okay. So that is taken care of that. So right now it's not a problem. But the major problem is the prompt engineering. Okay. So prompt engineering is anybody from computer science? Okay. Anybody from cyber security? Any? Okay, I'm telling you, this is the dangerous, okay, you have not seen. So every time you use your cell phone, your biometrics, your fingerprint, I can generate. I can use your biometric information. Every time you see your face with your computer, I can generate exactly your face information, okay. Now, without AI, okay, I'm telling you, but with help of AI, these things become much easier. Okay, so those every time you use, okay, this is the risk, this is the problem right now. Okay, that is we call this, the prompt engineering is kind of in cybersecurity called the cross-site scripting. Okay, I will give you very simple so you can understand. So when you log into any computer or any system, what you do, you use user ID and password, right, in order to log in. So, and you can log in. If I can take, instead of putting, I log in, instead of putting my user ID password, you put some kind of command, okay, it's a specially designed code. Instead of putting password, you put the code. This code will make your server dump and sending all your information. Okay, it will be, I can literally ask your server to vomit all your encrypted information. Okay, that is the problem of cross-site scripting, and that can be done with prompt engineering. So prompt engineering, if the smart people can destroy whole AI system. Okay, so somebody, the smart enough can destroy DeepSeek. Okay, it's not a problem. So right now people don't do that. Okay, but this is the reality. Okay, so now I talk about the problem AI makes enable our capabilities so much bigger. And now I'm coming to the quantum side. Okay, so I'm involved with some of the real quantum, and probably one of my students. We are going to publish a book, okay, how to build a quantum computer for small companies. Everybody in the world can make use, whatever based on your problem, you can create your own quantum computer. Okay, so that's we put one phase, one part is out, we already published, and other two, it's need like 3 volumes in order to build whole quantum computer using a low orbit satellite. Okay, so whole things. So this is my student, who is one of the Space Command previously, and work with NASA, and so those are some area. But okay, right now the real problem of quantum, right? So Google, you might have heard last couple of week in the news from Google, they build million qubit, the chip, right? And this million qubit they build now, they will build 10 million, and over a period of time billion. So what will happen? Every single cryptography, okay? So right now, so far we say our information is secure, okay? Let me. So far we say our information are secure, we encrypted all your data. But now this help of quantum computer, you can crack, okay, any complex cryptography in second. Okay, so right now current supercomputer take at least 100 years in order to crack, and I have access to every single supercomputer in US. Okay, so the highest US capacity supercomputers, one application I run and I make overwhelm every single our supercomputer. So there still the capacity, what we call, still we consider it's not that complex enough. With quantum, they are 10 billion times faster, and that will make a big difference. Okay. So one reason I said, I already explained you the having prompt engineering. And if you are smart enough to, it will. So I'm going to explain how prompt engineering can damage image processing, how you can manipulate your radar's image. Okay, so right now this has been a tactical something I will not able to allow to speak, but the general publicly published work I will share with you guys. So using adversarial AI tools, you can change. If you see the rocket coming, or it will say butterfly flying, or you see nothing is there, so your radar will not able to read correctly. And that nowadays, unless you are truly, if you are not using any computer, if it is purely manual, okay, not using any operating system, then only you may have able to have still safe. But today is so complex, you have to use any kind of computer. Without using computer, it's impossible, and that is the danger. Okay, so we are the 4 people in the world. I'm telling you, we built a system which run without operating system, and I can communicate around the world without anybody know nothing. They cannot, because we don't use a special mechanism we built. So this is we 4 people. Okay, we are the researcher only. You can imagine the countries, enemies, adversarial countries. Okay, those people are their life, and they spend whole based on that how dangerous they can develop. So that's kind of try to give you some hint. So those are the challenges. Okay. All right. So I told you, like, right now we don't need to worry. That problem was 10 years before. Today, this is because every AI or every application being use some kind of encryption mechanism, and behind the encryption is a math, what we call the homomorphic encryption. And this homomorphic encryption allow you train your model without decrypting. I don't need to see what data you have. Okay, still I can understand what's going on your training. So this is the way, therefore, Israel nuclear shutdown happened. Okay, so we don't need to know which area is happening, and still you can process. Okay, you can get exactly what you need. So behind this the mechanism we call federated learning. Means that you train the data without exposing your information. And behind this federated learning is, I said, homomorphic encryption. So homomorphic encryption is mechanism. I'll tell you how it works. So let's say you have the secure cell, okay, in which you have gold, very pure gold, and you want to keep there, and you want to make some kind of jewelry without opening that vault. Right? So if you open vault, like, people will know what password key you are using, then you will be so this mechanism allow you to go and modify your gold and make whatever jewelry you like without opening vault. Okay, that's how homomorphic encryption works. So, and behind this different homomorphic encryption, I'll try to give you a little bit. So some of the homomorphic encryption mechanisms are based on proxy re-encryption. So proxy re-encryption is the method. Okay. Sorry, I jumped a little bit further. That's fine. So these are the post-quantum homomorphic encryption. Post-quantum homomorphic encryption means quantum computer will not able to. I gave you example of third grader problem based on that. So I'm the inventor of couple of those post-quantum cryptography, and so those cryptographies being used. Okay, and so there are the mainly homomorphic encryption. Those people are with math, linear algebra, little bit interesting. Please try to look into this homomorphic encryption. Okay, so that will give you little bit more interesting stuff. So one of the mechanism. So far, when we solve quadratic equation, right? So how long it is difficult? How complex to solve quadratic equation? Okay. If it is a polynomial, if you have to, right? It's, and also like many variables right now, not only 1 millions of variables, millions of degree of polynomials, and your computer, or there's no way to, I say that quadratic equation even solving will take long time, and so based on that, this is called the learning with error. This focus on each number is kind of matrix of multi-dimensional. Okay, it's 1000 by 1000 matrix each element, and solving that is very impossible. And so if you get chance, look at it. So behind that is one of the how homomorphic encryption work. I give a little bit idea. So other most on a code base. This is solving some code. It is a McLeod's homomorphic encryption. So it's kind of idea is that nobody will about security is nobody about to solve that, and it will never reveal. That's the assumption. But if somebody, there are some problem in the computer science we call NP-hard problem. It takes thousands of years to solve the problem, but verifying take microsecond. Okay, so this kind of problem is very popular. If you solve the NP-hard problem, you will get $100 million. Okay, this is very popular problem in the computer science. Okay, NP-hard problem. So idea behind this NP-hard problem, I said solving take very long time, but verifying that answer is correct take microsecond. Okay, that's behind on that mechanism. So these post-quantum cryptographies are developed, and other one is multivariant. This is like relies on the, I say, complex problem. It's like many variables, and it's very hard to solve. So 3, 4, 5 variable system solving will take longer time, but this will be many, it will be thousand by thousands. Again, in the form of matrix. All right. So now, why we worry? What is the reason? Okay. What will happen? I just said. So quantum computer can easily solve most popularly used cryptography very easily. Okay. So that means any information secure you have today no longer secure within next 5 years, next 1 year. Trust me, or it's already been done by some government agencies. Okay. So every encrypted information is already. So here is the idea that you store today, and if you have quantum computer access to, I said I even be simple, want to give you the idea how to build a quantum computer, okay? And every small company can build a quantum computer. So this will happen right now. Only the gigantic companies are having the limitation. That's why we don't have access to quantum computer. But this new technology will give you easy. So Google's, I said. So there I will not go into different types of quantum computer, but let me quickly run the most dangerous part. So these are most popularly used cryptography today, and all of them can easily break by quantum computer. Source algorithm without using quantum computer. Okay, if you use source algorithm, you can solve. Okay, so if you have quantum computer and use source algorithm, then you can imagine what is the dangerous. Okay, so this another, the Grover's algorithm can reduce the any complexity by square root n. Like if you take, so you can imagine if it's taking n to the power n time to solve, yours. If it is on square root time, then you can imagine that, right? So it's drastically solve and reduce the problem. Okay. This is the current development and why everybody we need to worry and why we need some post-quantum cryptography. Okay. So US government and many government around the world and private company researchers, they came up with thousands of different cryptography, and out of that they selected 4 based on speed, based on security, saying that quantum computer will not able to break next 1,000 year minimum. Okay. The development will happen in quantum in next 1,000 years. In between, somebody smart may come up with new, new mechanism. They may reduce the 1,000 year to shorter also. So those things are based on prediction difficulties considering today, and so this is the force government, US government act. Right now impose, if you want to do business with US government, you have to use this cryptography. Any informations need to be used by, and this is impossible, disaster. Okay, so these 4 are the Crystal Kyber, Dilithium, Falcon, Syphinix Plus. So these 4 cryptography are based on lattice based, the math, very simple. So solving the lattice, the graph paper, right? It's like 1, 2 dimensional. But if it is multi-dimensional, 1,000 million dimensional lattice is impossible to solve. So based on those concepts, these cryptographies are developed. Okay. So right now, I think whenever we see quantum cryptography or quantum. So many times people interpret there is no quantum cryptography. Quantum cryptography means, like many textbooks also say quantum cryptography, right? Technically it's wrong. Okay, there is no quantum cryptography. Only the quantum mechanism, quantum phenomena, quantum principle are used to communicate, to share the secret key from one end to another end that behave on the base on the quantum, phenomena. And right now, in order to communicate, you need like if you use quantum computer to communicate and share secret key, you need like one quantum channel and you need one classical, regular, like whatever Wi-Fi, 5G, 6G, wireless, whatever you are using. So you definitely need two channel. And with this also, it's the difficulty, you cannot verify whom you are communicating. Okay, with quantum key distribution, this is the problem. Therefore, US government strictly for doing business in US or using are not allowing to use quantum key. Still some companies are used for their personal quantum key distribution mechanism for securing information. But idea is that you don't know whom you are communicating. That's kind of things NSA, National Security Agency, US government is little bit concerned about that. Okay? And I know over a period of time, but this is the large development, lot of investment are on quantum key distribution, the different techniques and method being developed, and European countries are putting a lot of energies and efforts. So it's very popular, but it's not popular in US because of the concern. So you only can communicate within your group using quantum key distribution. If you want to communicate with the outside, still you cannot verify whom you are communicating. So this is one of the problems. So I said you need to, if I need to communicate in space, okay, intra-space or intra-galaxies. Okay, so this is Panditji's presentations area where quantum communication right now can be helped in that way. So the mechanism is developed using only quantum channel. You don't need, you simply send the photons in space, and those are laser photons, very cheap, it doesn't cost much, and still you can communicate. And I developed the first single channel quantum key distribution method using those no-sum sequence. Okay, so over there, in the sequence I gave you problem, you are given the starting value and you need to find out a billionth of the value. You need to tell the sender. Okay, I send my starting value and the sender respond back me with the billionth value. If it is correctly matching, then then you start communicating. If it is not matching, then you still don't communicate. Okay, so that's based on that problem. So this is one of the application. I said third grader problem can solve this problem. Okay, so you can communicate intra-space using this mechanism. All right. So last one, I'm here to stop. So another way to optimize right now, using AIs and quantum optimization. Quantum has optimization. I think give the best optimizations because of quantum phenomena in nature. They try to in the phase lowest energy state, right? So that give you the optimal maxima. And if you want to use AI, you need to train AI, and parameter tuning is the most complex problem. And the ROCA is the reindeer cyclone-based algorithm. This is the Nature publication, published recently this year only in Nature. This can be used for optimizing, giving more and more precise training your AI. Okay, so. And I'll stop, and I look like you see I'm kind of busy. I can handle 4 questions. NIST is a standard, like the right. Oh, my okay, chair, please.
So
asking that what way the NIST NIST is responsible in the quantum computing.
Sure. So NIST is a kind of the standard organization which build every single standard, in the communication standard, even even wireless, even sending emails and all, like all those, or kilogram, milligrams, whatever the standard. Like the NIST is the National Institute of Technology, US government standard. They partnered with many governments agency and they said, okay, let's come. They took like more than 10, 15 years and to doing research and the different awards, and finally they came up with this for cryptography. And they came, okay, these are the same. People assume, and there are many other same still, those are not known. Okay. So cryptography, one of the example I said, my cryptography is not known to the people. And I built the original research in proxy encryption. Original invention happened at Johns Hopkins, and I was the first person to build the application based on proxy. I built the email system or file sharing system. I can control what time I can destroy data. I can control whom only I want to send this information. Only 5 people, 10 people, 1,000, million people. And they cannot forward, they cannot screenshot, they cannot print. Okay. So this mechanism is based on proxy encryption. So this is a core set platform I built. Whenever the developer, I gave equation and I said, okay, build the application. I hired the people from best programmer from Microsoft. And after 2 or 3 years, they were saying, sir, you need to give us software. I said, this is the software. Go ahead and build the product. And finally they build the product. Okay, I need to explain, giving one equations and coming up with the application. So right now WhatsApp is using similar kind of application. Okay, so why the WhatsApp informations are secure? I hope I answered Dr. Pandit.
One is what about the hardware? What is required for this?
For quantum communication, yeah, that's kind of a headache. So that's the reason, like the hardware, you need specific hardware for quantum key distribution. But if your organizations, you can have specific hardware. But if you want to communicate with outside, maintaining those hardware, maintaining the quantum, qubit phase, those are errors are, lot of error in that area, and can be, that's kind of the problem. But I said, if you have very tight system, still you can do, in Europe, they are having like 20, 30 different centers, and they communicate amongst them. And they can give to public also, you can purchase that key and you can use. So they provide, this is big, so right now this is the big business, quantum if somebody can build or develop qubit, quantum, secure communication method, it's very, very useful. And I did like in a couple of recently this year or last year, India government under Prime Minister's office, PM office, Dr. Chelly, like the DG and all, they wanted to come in US. They wanted to see our lab, and the US government didn't allow. And I said, okay, I will allow you, but they will not allow you to go inside. So right now this is the reason, and we are as a researcher, and we want to give to the public. And there may be a dangerous how to build, but something very basic we can give and people can build on, can apply. More and more people involved, then better and better thing will come. If only few people involved, then it will be within their monopoly, and there will be no what we market. So thank you. It was very interesting question. Any question? Okay, if anybody interested in quantum, so current I said is post-quantum cryptography is the most important way, one of the quantum applications. In AI is privacy optimizing, the AI also and having your AI model working on locally. So I'm building a system as working on local computer AI, and which will give you similarly like China's DeepSeek. You can use your cell phone and you can install that the language model, learning model on cell phone, and it will predict you like whatever it will create. That machine will be identical to you. It will be, if you are born, still you use that machine will do whatever you are doing. That machine will do. It will be digital twin of yourself. So and it doesn't stay on the local, so it doesn't go, your information is outside. So it will tell you, because I meet every day thousands, in the month, thousands of people. I may not remember what I talk, but the device is with me. It will tell you whom I told, what is the priority. So every evening you say, okay, this is the priorities of today. Every morning I get alert, okay, this were the number one priority, but now this is the number one priority. So those executive level people, this kind of AI has very, very valuable and very helpful, and it will make our life very easy. And I say this can be done with your undergraduate students. So my undergrad student, okay, just I teach PhD and undergrad also. Undergrad student also get starting salary $250,000. Okay, so no PhD student, even they graduate before graduating, because they have the skills. Okay, so same thing, if you have, you need a skill. I said you need to be able to solve third grader problem. I gave this and asked, okay, make sure create your AI, train your AI model, come too close to it. And that guy is hired in OpenAI. Okay, so this is good for those energetic new, even our older people. I call old school, and but we need to come up. We need to adopt the new culture, changing culture, because it's going to change. It's definitely going to change. So that's why I'm saying, putting AI topic everywhere, adding AI into your, whatever business you do. Okay, you either teach, you do research, or you do sales, marketing, whatever, it will help. Thank you.
Thank you, sir, for such an engaging and thought-provoking keynote session on AI and quantum computing. To honor his distinguished Vice President, I request Dr. V.S. Tripathi, sir, to kindly present the conference kit to Bharat Travel, sir. Please, sir.
We warmly invite all our esteemed guests, speakers and participants to join us for lunch. Please enjoy the meal and take time to unwind and connect. We will resume the session after the break with the esteemed Mr. Preet Yadav, sir. Thank you.
बैटरी है
Consider